Hi guys, this is lesson 16.1 part 2. So we worked on part 1 last week, and this is taking square roots and using them to solve quadratics. So last week we talked about simplifying the square roots down because that will come up when you're solving. Alright, so basically, our essential question, how do you solve quadratics? And in this case, we're using square roots. So this whole chapter is about solving quadratics. So if you forgot what a quadratic is, that is something where you have a squared in it. So we worked on factoring those expressions in module 15, so now we're talking about solving. Okay, so one of the things we have done before, I believe last year in our 7th grade accelerated book, we solved problems that looked like this. X squared equals 16, and you had to figure out, what would x be? So because it's x squared, it's basically saying what number times itself is 16. All right, so most people, mental math-wise, can tell me 4, but you also have to remember that -4 would work, okay? Now, so how this applies to if it wasn't such an obvious one is basically you square root both sides. So you square root x squared and you square root 16, and then you get the square root of x squared, since the square root means what number times itself equals the inside. This would just be x, so it just gets rid of the squared. And then this side is 4, but then since it could be positive or negative, which is what we worked on in the last section, you would put the plus and minus in front of it. Okay, so we did work on that a little bit. Now we're taking that, we're extending it to more complicated problems. All right, so let me go on to the next page and show you what the steps are. All right, okay, so basically when you're looking at a problem and you see that there is a quadratic, so there is something squared, the first thing you want to do is you want to get the part that has the squared on it. So get the squared part alone, or isolate it. Okay, so get the squared part alone. So anything that's not part of whatever squared, you want to get it to the other side with your normal solving steps. Okay, so let's start with this example. So this is going to use the steps that we just talked about. All right, so if we had something like x plus 5 parentheses squared plus 3 equals 39, and we have to solve it. So basically we're just trying to figure out what values of x would work in this problem so that when you add x to 5 and then you square it and you add 3 to it, you get 39, okay? So now using the steps we just talked about, so let me go ahead and switch colors so you can kind of see the difference. Okay, so the first thing we want to do is we want to get the squared part, which is this part, by itself. So we have to move the 3. So we subtract 3, and we get 36. And then over here we now have the squared part alone. So that's our first step. Okay. Now our second step is square root both sides. So we're going to square root this side and this side. So when we square root x plus 5 squared, since x plus 5 squared really means x plus 5 times x plus 5, we just get x plus 5. The squared goes away. And then over here we get our 6, but we have to put plus and minus in front of it. And that does make a difference, okay, because there's actually more than one answer that works for x here. Okay, so now what we're going to do is I'm going to show it to you where I separate it. So since I have two things here, I have a positive 6 and a negative 6, I basically create two equations. So my x plus 5, and then I put equals positive 6, and then I do my x plus 5, and I equal it with negative 6. Okay, then I have those two equations that I solve. So I would then just do my normal solving steps. So subtract 5, and I get x equals 1. And then over here, when I subtract 5, I get negative 11. So x equals negative 11. So there are my two values of x for my solution to the problem. Now, if I wanted to check it, which I'm just going to talk you through it real quick, I would plug it in. So I would do 1 in the parentheses up there. Okay, 1 plus 5, which is 6, and then I square it, which is 36, and I add 3 and I get 39, which is what it's supposed to be. Okay, if I plug in the negative 11 up there, so now I do this one, negative 11 plus 5 is negative 6. When I square that, I get positive 36, and I add 3 and I get 39. So then I could see that those two answers do in fact work. All right, let me show you another problem. Okay, so let's do one where the value isn't a perfect square, so you know what to do with that, okay? So let me switch my color back to black to start. All right, so, okay, put up my wrist guards, I don't write on there. Okay, so example number 2, 4 parentheses, x plus 3 parentheses squared equals 12. Okay, so my first step, again, I want to get the squared part alone, which would be the x plus 3 squared. Okay, so I have to get rid of the 4. Now, this time the 4 is multiplying with the x plus 3 squared, so I'm going to divide the 4 to both sides so that I get x plus 3 squared equals 3. Okay? So now my next step, now that I have the squared part alone, my next step is to do the square root of both sides. So I'm going to do the square root of this and the square root of 3. And so when I do that, I get x plus 3 equals positive, negative, but now I don't have a perfect square. So what I do is I just keep it as a radical, so square root of 3. All right? And yes, I still have to complete the next step. Okay? So the next step is to get the x all the way by itself. So we're going to go, if it says x plus 3, I have to subtract the 3. And I'm going to subtract it to both sides. Now this is where knowing what to do with all this right here. Okay? So what you're going to do basically is you're just going to put that negative 3 in front of the plus and minus symbol, and then the square root of 3 goes behind it. And then since you can't actually add the square root of 3 with negative 3, you just can keep it as one expression, or you could separate it to two expressions, one with a plus square root of 3 and one with a negative or a subtract square root of 3. Okay, so those two answers mean the same thing. It's just quicker to write it with the plus and minus symbol. Okay, so there's just one more thing real quick before I finish up the video, and that is what to do in the case of something like this. Okay, so this is the last example, but this may come up in your problems. All right, so this one we're going to do 3 parentheses x minus 1 parentheses squared equals negative 15. All right. So we're going to get the squared part alone, so I need to divide out the 3, all right, so divide 3, so that I can get this part alone. So I get x minus 1 squared equals negative 5. All right, so square root both sides. So if I square root the left side, I'm just going to get the x minus 1. And when I square root the right side, I'm going to get the square root of negative 5, and I can put the plus and minus. But this is what I want you to watch out for, because as we've talked about before, I can't do the square root of a negative 5 right now. Now we have talked about in Algebra 2 how you talk about imaginary numbers, but we're not at that point. We're in Algebra 1. So this is actually one where you can't solve it. So it has no real solution. Okay, now we don't just say no solution because it does have that imaginary solution that you'll learn about, but it has no real solutions. There's no real number because of the square root of negative 5. So once you notice that you're going to end up with the square root of a negative, that's when you can see that it's actually just a no real solution. Okay, so let me give you the problems that go with this so that you know what you should work on to practice. Okay, so this is page 567. These are different problems than last time. So this is number 7 through 13. And 569, numbers 26 through 38. All right. Hope to hear from you guys soon. Send me a message if you have any questions.